Thank you for coming. Thank you also the people seated outside. I'm glad to have this second meeting about all the polymers and the additive, about all the flame, etc. We think, thank you to position me. We think that it is important for everybody to make some culture about of the plastic and the polymers as well, because when I made the study in the university a long time ago, because I'm old, very old, at those time in the engineering, the polymers was this topic very, very unknown. So I have a pleasure that we introduce the plastic material in the world and the young people that are facing the future. Thank you everybody, and good lesson for all.
Today's course, Senior Technical Specialist Additives, or company RVT Consulting, and we will have a presentation about fundamentals of stabilization of polymers, processing, thermal light stabilizers, and antioxidants. Roberto, please, it's your turn.
Thank you for the nice introduction. Also thanks to Kraus Maffei and to Green Chemicals to give me the opportunity to be here and to share some knowledge on stabilizers. So I will start. With the presentation online. So I will give you a little bit of market figures. You know, you always have to know what the field is, what you're working in, how interesting is it, or how difficult is it. Then I will tell you about the mechanism of degradation and stabilization, and I will do that for the different classes of additives or stabilizers. So what I would like to have that by the end of this presentation, you will have a clear idea about the difference between an antioxidant, a phosphide, a thioester, a Hals UV absorber. Because, you know, if you're not too familiar with it, you just, you know, it's like a pot, you know, it's a stabilizer. But, you know, it's more than that, and you will see it's very exciting if you know more about it. At least I find it. So then I will go through some applications, and you will see the morning will go very fast. So if we look at the pie of additives that are used in polymers, you see that the pie is big, but it's not so big, but you know, you have a lot of additives jumping in that pool. So you have flame retardants, you have stabilizers, you have surfactants, so antistatics, antifogs, you have compatibilizers, lubricants. And if you put that all together and you look at specifically at the stabilizers, that's the red thing there, you see that it's only 10% of all stabilizers. And this estimation was done in 2013. So just for your idea, in 2013, it's already 10 years ago, it was 560 kilotons. What you just have to do is, each year you add 5%. So the stabilizer consumption, in principle, increases at the same rate as the polymer production. And the polymer production, the last 10 years, you know, you had good years, you had worse years, but in principle, worldwide, you know, I say worldwide because that can be much different from country to country, it grows by 5%. So don't forget that if something grows by 7% during 10 years, you double the amount. So 5%, 10 years, it's not bad. So you know, it's not anymore 560, it will be more 750. But still, 750 kilotons, so 750,000 tons is in principle nothing compared to the production of polymers. You know, one plant of HDPE, you know, the super modern ones, they make 500 kilotons. 10. And here is, you know, the phenolic plant. This is the phenolic plant 76. Mostly used in Europe. Then there are some other ones. You can say, why are they so different? Can you not just make a phenolic and use it? Don't forget that these have been developed in the years 50, 60, so 90, 50, 60. That is when the world was not global. You had the US, you had Europe, you had Japan. And they all developed their own phenolic antioxidants, and they were very proud to have their own. So in Europe, you would not use an American one. The US would not use European one, you can imagine, and not the Japanese one, of course. And Japanese, they are the most advanced one, They will only use theirs. Whatever you can do, they will not use yours. Today, that's why today still, if you go to these different regions, Asia, Europe, North Africa, US, South America, you will see distinct additives which are more used there because of historical reasons. So these are European ones, these are American ones, this is the chicken. So you will still see that. These are things that you don't just eradicate.
Everybody online, if anything, please just let us know and we'll try to fix the problem. So, Ernesto Giovanni, I'm the sales manager from Polymers, in charge of additive from our team for Europe. I'm very pleased to be here today to give a small lecture on the metal deactivators for plastics. Very briefly, this is a kind of a spin-off from the nice presentation you had from Roberto this morning. Next slide. Oops, yes. So we'll go through a brief introduction, a quick view on the polymer degradation, because this was done extensively and very nicely from Roberto this morning. We'll go through also the polymer stabilization and the effect of metal deactivators, why to use them. Then I will go through briefly the key products and give you some example of application testing before to jump into some application example on the use of metal deactivator in the real life. Which will attack the polymer, which will contribute to the degradation. So you have two levels of degradation somehow. Again, be careful. This scheme for auto-oxidation of hydrocarbon polymers is a theoretical scheme. But so far we don't have anything better. And we have been relying on this for several decades. Let's jump into the stabilization and the principle of metal deactivator. So keep in mind degradation, radical process. So we have seen that the degradation mechanism coming from metals, actually metals, we are talking mainly about reactive metals, which can be either oxidized or reduced and transformed into a metal ion. That metal ion will catalyze the creation of peroxide radicals. And they will do the job of destroying the polymer. That's the degradation mechanism. Luckily, there were products called metal deactivators which can overcome that degradation induced by the metals and the metal ions. So basically, metal deactivators, you see one example here, NDA 1024 is one of them, broadly used, well-known products. His job will be to quench
the range of the application that we can use plastic into different applications. So the benefits of nucleating agent can be improved clarity and haze, improved strength and stiffness, improved HDP heat deflection temperature, reduces cycle time, reduces warpage and more uniform shrinkage, which can lead into faster process time and improve, of course, aesthetics of the product. Now, if this shaded part is what the normal resin provides, we like to create something like that. In the perfect world, this looks very nice, but unfortunately, this is not really the case. But we try to do our best to do. So, where can we use the nucleating and clarifying agent? In majority, we use in semi-crystalline polymers, which is PP, PE, PET, PBT, PET. This we cannot. It's not used in amorphous polymers because of the molecule. There's no packed. The molecules are randomly packed, and there's no clear crystalline molecule that we can use as to nucleate. Also, the polymer, the rate of crystallization of the polymer cannot be too slow or too fast. So for example, HDPE is not widely used, nucleating agent is not widely used, and it's not too effective. But that's not really the case here. So what do you need to know? You have to have a right resin, you have to choose the right resin type, right FMFI, so on and so forth. Choose the suitable additives, soluble for clarifying agents, insoluble, a micronized nucleating agent, depends, so you have to know this. It could be a combination of nucleating agents, additives, that you can try to achieve different level of values in HDT or TC or FM, but this is more on the test and error. And be ready for compromise, because honestly, when you try to improve one, another goes down. So it's not an easy fix. So you have to be really ready to see where is the compromise. If you want to try to achieve a real clarity in the polypropylene, you may lose some of the other mechanical properties. And